Hi everyone, in this video I want to show you how the application my colleagues and I designed and developed as a final project in the Hackaboss Data Science and Artificial Intelligence Bootcamp. So our goal was to build a Streamlit app that allows the user to visualize data from the Spanish electric network. Ultimately, the application would allow the user to deploy some neural network models to predict the electricity demand of the country. So to achieve this, we designed the entire ETL process, ensuring that data was properly extracted, processed, and stored in a well-structured database. I won't go deep into very technical details, so I'm just gonna show how the application works. And well, just left to say that this project was developed by Javier Corrales, Ignacio Barba, and myself, Álvaro Mejía. So if you're curious to see this application in action, just stay with me and let's explore how the application works.
All right, so we have our app running already. As you can see, everything is in Spanish, but I'll walk you through everything step by step. Landing page is actually quite simple. It contains just a brief explanation of what this application does. Essentially, we've developed a user-friendly interface that allows anyone interested in the Spain's energy sector to easily visualize data. So we focus on four key variables, okay? The first one is the energy demand, which is the amount of energy that the country needs. The second one is the energy generation, which is the energy that is actually produced by the country. Then the energy exchanges, which is the energy traded with other countries, and the energy balance, which is the difference between demand and generation. So all this data is sourced from the API provided by the Spanish electrical grid, and we've managed to collect all available records from 2010 to the present. So let's check out the app structure. Here, as you can see, the app is divided into three main tabs. Four, if we include the home page. So apart from that, the first one would be data analysis, where we can visualize various charts and explore energy demand predictions using machine learning models. Then it's a machine learning tab, explaining the models used in this application. And finally, a little bit about us, introducing the developers behind this project. So now let's dive into the first and probably the most important tab, which is data analysis. This section contains four subtabs where we can explore different datasets. The first one is demand visualization and prediction, where we can select which data from the energy demand we want to visualize, choosing from the last 7 days, last month, last year, and the entire historical dataset. For example, selecting the last 7 days, this will display a plot of the weekly energy demand. We can filter by region, we can customize a little bit more the view, toggling this off on the different subregions. We have Canary Islands, Balearic Islands, mainland, the whole national energy demand, etc. So when viewing the last 30 days, for example, we start noticing some interesting patterns. The demand typically follows a wave-like trend, dropping significantly on weekends. This is a well-known weekly energy demand pattern. It's just lower consumption on weekends. Now, if we select the last year's data, we will observe also some seasonal variations of the energy demand. This tends to increase during the summer due to the air conditioning usage, and also during the winter due to the heating systems. However, there are two exceptions. The demand drops significantly around the August 15th, and also uh, during the week of the Christmas week, right? Eventually, if we analyze the fall historical data, we see notable trends such as the steep drop in energy demand during the first quarter of 2020, mainly due to the COVID-19 pandemic restrictions. You may have noticed that when we select the last 7 days or the last 30 days, we have the option here to enable the demand predictions. So once activated, we can choose how many days to forecast. The next 7 days, next 15 days, or the next month. We can also choose one of the four models. The models are explained in detail in the machine learning tab, so we will walk through them later. And once we have everything selected, uh, the graph displays here the right side. So we have three different lines. The first one is the blue line. These are the actual demand values, the most recent values we have. And then we have the forecasted values in dashed green and red lines. So the green represents the immediate predictions. These are one-step predictions. This means that the model is using the entire historical dataset to predict all the future days at once, while the red is representing the stepwise predictions or multi-step predictions, which the model is predicting each day iteratively based on previous predictions. Let's move on now to the next tab, which is the energy exchange map. So this interactive map focuses on Spain's energy imports and exports with neighboring countries. So we can select a time period here, and this map will show countries in different colors. In green, those which Spain has exported more energy than imported from. And also here in blue, for example, France, where Spain has imported more energy than it's exported. We can also click on one of these country markers and it will display the total exported energy in gigawatts per hour, the total imported energy also in gigawatts, and finally here the final balance, which in this case with France is positive, which means that Spain has imported more energy than exported to it. Good. So next up, this is the annual comparison tool. So this section allows the user to compare energy data from 2 different years. We can analyze the 4 variables we've been talking about, the energy demand, balance, generation, and interchanges. And we can select here the 2 years we want to compare. So at the right side, we can already see the plot with the evolution of the demand along the 2 years selected, 2019 and 2013 in this case. So apparently we can, comparing these 2 years, we can see a slightly higher demand during 2019, and also the annual patterns we've been talking about too previously. Here more energy demand during summer and more energy demand during the winter. If we scroll down, we can also see a couple of box plots to see a little bit better the, the data distribution. Now taking a look to the energy balance, we can see here an interesting insight. So in 2019, Spain had a negative balance, which is a huge contrast compared to 2013. This means that during this year, there was insufficient energy production in the country. If we move on to the energy generation plot, we can see here a sharp drop in energy generation during the second quarter of 2019. So finally, checking out the energy interchanges, we will see a different plot, different to the previous ones, because here the data are also split in imports and exports. So it makes all the sense that here during the second quarter of 2019, there's significantly more imported energy. So last but not least, this tab shows the energy generation by technology. So this section breaks down total energy production by generation type. We can select time period here, also the generation area, and this will show a plot with the energy generations already split by technology. I already left here the main ones, and well, we can extract several insights here. For example, the red line is the solar energy. As we can see, the production is higher during the summer. The contrary happens with the hydropower. It's the light blue line, which in which the production is higher during the winter. Another interesting insight is the green line. This is the wind energy. So as we can see, it's very irregular. A lot of peaks. This technology is very dependent on the climate conditions. But it's true that it's usually stronger during the winter and the autumn. Also, we can take a look to the nuclear energy. It's the dark blue line. As we can see, it's much more stable. It won't depend on the climate conditions, so the energy generation in this kind of technology will be always more constant. Additionally, also a couple of pie charts are provided here. If we scroll down, we can see the share of each technology in the total energy production. And here we can also see the renewable versus non-renewable energy generation. So in general, Spain usually generates slightly more renewable than non-renewable energy. So finally, we just have a couple of things left to check out. The first one is the machine learning tab. Here we have an explanation of how we use the machine learning models to predict the demand. Here we can choose the four models we're using: the simple RNN, STM, GRU, and the Facebook Prophet. So a small explanation about this particular model will appear here. We also have the metrics we got for this specific model, and finally here a plot with the loss functions both for training and validation phases. And finally, the last tab, we introduce ourselves, the development team, Javi, Nacho, and me. So that would be all from this application.
So just to conclude this video, I'm just gonna say that this project has been a highly rewarding experience. I truly enjoyed collaborating with my colleagues, and I was actually very lucky to have both Javi and Nacho with me. We've learned a lot along the way, and of course there are several areas in which we could work to improve our application. The first one is the performance. The application still experiences some latency. Then the database integration, the ETL process, we could improve them to enable some real-time data updates, and also try to enhance the model's accuracy. They perform quite well actually, but there's always some room for improvement, right? So overall, this project provided us valuable insights into data engineering, visualization, and predictive modeling. So this is it. This is the application. I hope you enjoyed, and thank you very much for watching.